Hi guys, so I'm just going to finish going over our notes from the other day on classifying real numbers, and then this will help you work on the homework. Any questions that you might have or any trouble, we will go over in class the next time I see you. So rational numbers, as we mentioned the other day, are numbers that can be written as a fraction. And so that includes just regular fractions that you see. It includes terminating decimals, like 0.63. It includes repeating decimals. Integers are a subclassification of rational numbers, and they basically don't include the decimals or the fractions. Okay, so you have, let me write that in there, no decimals and no fractions from the rational numbers. Whole numbers are a subcategory of integers, and so that's why the circles keep getting like smaller and smaller. Whole numbers are a subcategory of integers, and they basically don't include the negative numbers. They start with 0, 1, 2, 3, etc. And natural numbers are the smallest subgroup of rational numbers, and they don't include 0. There's no number 0. So you just, when you were a little kid, you naturally started counting with 1, 2, 3. And then on the other side, you have irrational numbers. Irrational numbers are infinite, and they don't repeat. No repetition. So pi is one of the most famous examples of an irrational number. It's 3.14159, and it goes on forever. That's why we put the dots, what's called an ellipsis, and it goes on forever without any repetition. So unlike, for example, on the other side, 0.012 repeating, that's 0.0121212. That's repeating, that's rational, but pi is irrational. Other numbers that are irrational are square roots of numbers that are not perfect squares. Square roots of numbers that are not perfect squares. So, for example, the square root of 25 is 5, because 5 is a perfect square. 5 times 5 is 25. That's rational. But irrational would be like the square root of 8. There's no whole number times itself that equals 8. So this would be irrational. That when you take the square root of 8 on your calculator, you'll see a pattern that looks like pi. You'll see a number that goes on forever without any repetition or any pattern. Okay? So other examples are like the square root of 7, the square root of 6. None of those numbers has a number times itself that equals that number. So therefore they're irrational. So just to go over classifying some examples. Examples I'm going to put down below, and we're going to put them into the Venn diagram. First example would be negative 2.1. So negative 2.1 is a decimal. It's negative. It's rational. Any decimal, if it's repeating or terminating meaning it has an end, would be rational. Okay, so if I asked you to list the categories it belongs to, you would say it's rational and it's real. All numbers are real. Here's another example, negative 12. So take a minute and think about where you would put negative 12 on the Venn diagram. A negative 12 would go here. It's an integer, it's rational, and it's real. So because each circle is inside of the other category. So integers basically are negatives and positives, but no fractions. Exactly, no fractions, no decimals. Okay, here's another one, square root of 81. So think about where you would put that. Now, 81 is a perfect square. 9 times 9 is 81. So the square root of 81 is 9. 9 falls into the natural number category. Well, actually, what we should write in here is the square root of 81. Okay. So 9 is natural, it's whole, it's an integer, it's rational, and it's real, if you were to list them out. It belongs to basically every category on the left-hand side. Here's another one, square root of 12. So you'll notice there's no whole number times itself that equals 12. So 12 is not a perfect square. So the square root of 12 is irrational. So it's irrational and it's real. Here's another example, 8.6666 repeating. So remember, all repeating decimals are rational. They come from fractions. So it's rational. It goes on the left-hand side over in the rational number category. So it's just rational and real. Another example, 2/3 pi. Now 2/3 is rational. It's a fraction, but pi is not. Pi is irrational. Anything that involves pi is going to go into the irrational number category. Okay, here's another one, 20/5. Now 20/5, if you think about it, is a problem that can be simplified. 20 divided by 5 is 4. So think to yourself, where would I put 4? And 4 is natural. So you would put it right in the middle. 20/5 would go right there. It's natural, it's whole, it's an integer, it's rational, and it's real. Okay, we're going to do 2 more. Negative square root of 100. So 100 is a perfect square. So this is really negative 10. If there's a negative on the outside, it goes in front of the number. 10 times 10 is 100. So negative 10, think about where would negative 10 go? And negative 10 is an integer. So this would go right here in the integers category. Negative square root of 100 is really negative 10. It's an integer, it's rational, and it's real. It's not a whole number because whole numbers can't be smaller than 0. They can't be negatives. And finally, last one, we'll do 3.7984. Think about where you would put that. And so 3.7984 does not continue on forever. There's no ellipsis. There's no 3 dots. It terminates. So that would be rational. That would go here, 3.7984. Okay? So ask me questions when we get to class, and this should help you on your homework. Okay? Thanks.